Hey everyone, today we will demonstrate how to connect data collection system with AVEA ventilator. This is AVEA silver model. So first, to connect this AVEA, that is a 4th generation ventilator, with a laptop system, we will start it. So first we have to put the settings of the patient that is newly entered to the ICU. So let's say new patient, except we have to make this alarm silent. It will be silent for 2 minutes. Then we have to start the automatic airway compensation system, let's say on, and we have to put the ET tube, the endotracheal tube, which is used by the patient for invasive ventilation. If it is non-invasive ventilation, then there is no need to on this automatic airway compensation system. So this, to accept this, we have to use this touch, turn and touch system. So again touch and again touch, sorry. So now this 8 mm diameter of the tube is selected. So to show you which tube we are telling about, so this is ET tube. From here, this is the inlet side of ET tube and this is the outlet side. So this is so if you will see here, there are some marking over it. So this marking is ID 8 mm. It means its diameter is 8 mm and its standard length is 30. Okay, so that length we have already here, 30 centimeter, and diameter is 8 mm. This is called as cuff, which is to be inflated using with the help of air. The main purpose of this is the ET tube will not shift its position during invasive ventilation mode. Further, if the patient is on ventilator for long duration of time, we can use tracheostomy in place of ET tube. This is more comfortable comparative to ET tube, especially during invasive ventilation mode. So after selecting these settings for ET tube, it will give increase it will compensate the pressure drop during this ET tube automatically. That's why it is called as automatic airway compensation. Now we will select the patient side. By default we are taking it at adult, so let it to be size to be accepted on, and let it to be 8, and leak compensation. So in breathing circuit, from here, this is the point or the A wave from where the air is coming out. Then it will go to this humidifier. Here there are some marking scheme up to which we have to put the distilled water and the air get humidified. Then through this pipe, this is called as inspiration limb, and through this wire it will go to the patient. So for demonstration purpose, we have used here test lung, and then after inhalation it will go through this pipe to exhalation. So if there is any leakage, for example, let's say there is some airway leak from this point or any other point, then that is compensated automatically by using this leak compensation on, and other things remain to be said. Let's say it to be accepted. So to change the mode, we can use these settings. Let's say screen, sorry, for mode we have to click here, and these are the certain modes which this AVEA ventilator offers to us. This is these are called as machine triggered modes, and these are called as patient triggered modes. And we initially, let's say, as here there is no patient, so we are putting it on default volume AC mode. We can change this by clicking this and by mode acceptance. So let's, by default we are taking it on volume AC assist control mode, and we accept it. So in volume assist, volume is the controlling parameter. Once during inhalation it will reach to certain specified value of volume, it will stop inhalation, and for this inspiration pause time we can increase this. It will, after this inspiration pause, it starts exhalation. So here you can see on the screen we have various waveforms as well. These are called as tidal volume, flow waveforms and pressure waveforms. We can change the scale as well of these waveforms by again using touch system. Okay, so here also you can see we have to change its scale. Okay, we can set PEEP as well and other settings as well. So these are those settings which are adjusted by the operator or doctors, and these are those settings which are which are actually the measurement of what actually happening in the patient. So these are not in our control. In our control we have these settings. So other than this, so before for data collections we have to do some attachments, some electrical circuit we have to make. So first is called as RS-232 protocol based electrical circuit. So let me demonstrate you this one. So this is simple Ethernet protocol, Ethernet wire. This is actually T568V type Ethernet wire. This is you can easily find out by using its color coding. You can see it is beginning with the orange, white and orange color Ethernet wire. Total 8 wires are there. So in other side also it was RJ45, but we customized it to, we removed this wire and we selected out some only 3 wires out of it. Those are receiver, transmission and ground wires. So this depends upon what kind of pin layout is there in AVEA, where we are going to connect this this portion. Okay, so here we are attaching it at we shoulder it over a DB9 female port. So this is pin number 1 to 5, then 6 to 9. So we have to attach it on 2, 3 and 5 receivers, transmission and ground pin. It depends upon the pin layout of the AVEA ventilator. So after this, over this we have to attach this one. This is serial to USB converter, and this USB converter is male type converter. This will go to the female converter and it will be attached to the laptop. So the total electrical circuit, it seems to be RJ45 to female DB9 and then female DB9 then male DB9 to USB converter. So to connect it, there is a port here on AVEA ventilator. You can see this is MIB port, and here we have connected this RJ45 below. This is in the back side of the desktop, and then this is the complete electrical circuit we have created. So this you can see, this is the same, that 8 wires out of which 3 are selected, depends upon the pin layout of in AVEA, and this is female DB9 and the male DB9 is attached over it. Then it will goes to the laptop USB. So in this way this system, electrical wire network system, is created. So now for data collection, actually the AVEA ventilator not only has these parameters, it has number of internal parameters also, which are not shown over display because they are not usual to the doctors or usually required by the doctors, but actually it is calculating a number of parameters. So for our research purpose we need all those parameters, not only those parameters but also the waveforms. So in parameters also we have monitoring parameters, we have settings, we have alarms. So alarms is simply, let's say initially it was showing like there is a safety valve alarm, so there it will be stored as 1, that this alarm is bringing. So let's say if the alarm is of low tidal volume, that low tidal volume it stored as 1, like the alarm is of low tidal volume. So similarly it has 91 such alarms and 60 monitoring parameters values and 60 settings. So how the settings vary from monitoring values? So let's say I am increasing here BPM suddenly to, let's say 23. So actually the settings are, it will be reflected in real time in settings, but to the patient this is not the actual BPM which is given to the patient. It gradually increases to that value, so that will be reflected in monitoring values. So that is the difference between monitoring as well as setting parameters. So let me back it to the same. Okay, so now let's start. So up to yet I have demonstrated what are the various settings we have to do. Other than this, we have to click here on this button screen, and then we have to click here on utility. We have to click here input and output, and we have to set here this this RS we have to set here. We can change by scrolling this, and then we can accept it via VOXP. We have to change its baud rate to 11.52200. okay, and we have to accept the settings and main. So these are the changes we have to do. So summarizing is, we have shown you the electrical circuit, we have shown you the what are the various settings, what are the various parameters and waveforms noted by these ventilators, and what are the internal changes to be done in the ventilators. So now back to the laptop where the data is going to store. So so let's start this this demonstration. Okay, so for data collection we are using this VOXP research data collector. So let me start this. So this is AVEA's own data collection system, and so let me show you if it is visible to you or not. Yes, I think it is visible. So now continue. We have to put here some pin given by AVEA, and now first we have to put the patient initial parameters. So that we will put from here new. So these are the some settings which I have default, this is customized by me, sorry, depends upon the requirements based upon my research. But yes, we can change it from here, option, and we can change here the template, customize the template. So these all are the initial parameter that I am noting of the patient, like first name, bed number, age, gender, height, smoking index, asthma patient, or these are yes no, like is he suffering with asthma and all. If we want, we can add new also. Let's say the patient, let's say a patient family history, is there any such tension environment, or you can say, let's say patient employment history, his working environment is like that, it is it is going to influence his respiratory system. So we can put here employment environment like this, and employment environment. Okay, so we can put here, and we can change here, like it is to be compulsory, has to be filled true, and other things we can make it optional, and we can have put a, so in this way this can be stored. But okay, we do not want this, so I'm not saving it. So let me check it is saved or not. Customize template, no. Okay, it's good. So let me back. Okay, so let's say new patient enter, and we have to put his first name. Let's say my name Rishi, is this on bed number 1, its age is 24, gender is male, height is let's say 6 feet, smoking let's say no smoking history, none, smoking index let's say by default 100, asthma patient let's say Y, COPD is no, ILD no, MI history no, hypertension no, and diabetes no, and diagnosis let's say he is suffering with COVID. Okay, so we just have to put okay. So these all initial data are stored here, which is going to be stored in .xpat format. So let's start now data collection. So this is very light software, it will not take too much time. So initial data of the patient is stored. We have to choose the language. Continue. So here we have to check on which COM port it is attached. So let's say it is on COM 3 we have, and we have to test it. So once it stops blinking, it means connection has been established. So now it's stopped blinking, so connection has been established. Now again connect. So it will take 20 to 30 seconds for connection. So this software is mostly used for research purpose. It will collect 60 monitoring values, 91 alarm settings, and 60 settings, and 10 waveforms. So that I will demonstrate here how. So let's say we want to customize what parameters we want to store. So this is generally the platform or the page where we can change these settings. Cross means these are those settings which we have to store. Let's say I don't want flow, so I have to change it to, I have to untick it. Otherwise, if I want flow, I can tick it. So in this way, I need all these 11 waveforms. So these are the monitoring parameters I am storing, all 60, and in next page 61 work of breathing. These all parameters I am noting. If I want, I will deselect it. Alarm settings are there. Similarly, 91 alarm settings, and settings 60 settings, 62 settings, and this is just the system data. So let me make to be ready. Okay, so we are storing everything that this software will provide us. So this will stop the default recording, because now the parameters which we want is changed. Here configure events, we can put here what kind of events, if any events is going on. Let's say patient here I have edited, we can like suction, like if doctor wants that they want to record these events, like now, like the time period at which the suction is initiated. So this software has the ability to record that event as well as. So in this way I have put it down the 3 events, or you can add here others as well based upon the requirements. Okay, other. Okay, ready. So let's start now recording. So here initially it is red cross, means right now maybe recording takes place, but it is not storing anything in the laptop. Okay, so now this time has been started, 3 p.m. 44 minutes and 12 seconds, and breath count begins, means recording started. If you want to store the monitoring values, settings and alarms, you have to click here start. It will go to the default directory, which is which is as per our own requirement and own adjustments, and this is the folder name that is also default, the first 3 letters of the first name and the bed number. And along with this we can record waveforms also. So this monitoring value will directly go to CSV file, but this waveform will store in some less memory consumable format, which will be further changed to CSV. So if we want to see, we have to click here waveforms. So here we can scale it. So we are getting 10 waveforms, depends upon the patient. Right now we do not have any patient, so we are storing only flow expiration, flow inspiration waveforms. Depend upon like it is a spontaneous or non-spontaneous type. Then end tidal CO2 pressure and tidal volume waveforms. Similarly, we can see if let's say now we want to record the event. Now let's say suction begins, so we just have to click here, and it will record the time corresponding to which this event begins. Similarly, we can get here monitoring values, and if we want something else, let's say we want dynamic lung compliance, so we can get that also. And IE negative means inhalation is greater than exhalation. Okay, and we can get here loops as well. This is basically flow versus pressure loops. That will be further, we will get other loops based upon this waveforms data. Okay, so now back to the main. Now if we want to store these all values, we have to take the exit from here, and we have to click this one. So this is the monitoring value which we got from this recording. So this is the time. Here you can see the exact time, and these all are the monitoring parameters which we are getting. These are the alarm settings which we are getting, 0 because there is no alarm, and these are all the settings. So in this way we are getting 60 monitoring values, 60 settings and 91 alarms. And to get the waveforms, we have to click here and we have to start convert the waveforms. Okay, and now waveform conversion, we have to move this red lines to the left possible, so that we have to start the recording at the beginning. And let's say export to CSV, so we have to 50 times x, so increase the speed of conversion. So already stopped, now converted, so stop, exit. So now here you can see we have the waveforms as well. So these are the waveforms. So now let me tell you the how much is the time period or frequency of data collection. So its frequency of data collection is in microseconds. Here you can see the 39 seconds is going on at column 2, and it will go to okay, so this will go up to 87 because that will begins at 140. So total 100 columns per second means it is frequencies 100 hertz. 100 data it is recording in 1 second, especially in waveforms. So in this way we are getting 10 these monitoring values, settings and alarms, as well as this waveforms data of 10 waveforms of the various parameters, and those parameters are flow expiration, flow inspiration, flow waveform matrix, EtCO2 and tidal volume. So in this way we are able to record the AVEA's monitoring values, settings and alarms along with various waveforms in real time that will be further used for research purpose as well. Thank you so much.